Hello, this is assignment 2, and for problem 1 we had to modify it so that it looks something like this. So for problem 1, the main thing was that we had to change the vertex buffer, and we had to change it so that it took us as a simple vertex, and I defined a simple vertex as a vector of position and a vector of color. And then since we changed the vertex buffer, we also had to change the size of the vertex buffer. And then we would also have to change the input layout of the vertex buffer to take in position and color. And then we would also have to change the shaders. So for the vertex buffer, a vertex shader, it would just pass in those two input parameters, and then the pixel shader would also just take in those the pixel data as a input, and pixel data is defined as SP position and color. So if we run this, yes, we can see that we get the same image that we see on the homework screen. And so then when we go to number 2, we kind of have to do it but without the gradient. And in order to do that, we're basically going to be defining more vertices. So there's 16 total vertices now, and then there's still 6 triangles, but then we'll be utilizing like vertices that have the same value, but they're going to be obviously outputting a different color, because that's how the triangle will be defined. And with that, we will get the sharp looking edges that we see that we need for problem 2. And that's where we see the boundaries coming in. And then for problem 3, we had to modify the demo, and we need to run the project. And basically we were switching the input layout of the vertices for the vertex buffer, and since we're doing that, then we would have to, in order to get this working, we'd have to change this in our layout so that color is on top and then positions the second element. And then if we run this, it should work. And there, it's showing up and it's working. And then for problem 4, we had to use a constant buffer and to create an image that looks like this. So I defined the struct, the simple vertex, and the CB color in my .h here. So I define CB color, and it has 2 columns for the 2 different colors, yellow and red, and then also define simple vertex. And then we define the indices, which is the same one as before in problem 2, and the same thing for the vertices. The thing that I had to change was the layout. Instead of a color now, it's a color number, and change the format to R16 unsigned int type, because we're just taking a number. And then we also had to define the constant buffer and prepare it. And so we also had to select define the color values for that. And then also we had to give the visual shader access to the constant buffer, because in my example, the visual shader uses the constant, the shader constant active call that it gets from the constant buffer. And then, as you can see, it gets the 2 input parameters from the vertex, and then it uses that to change the color depending on whatever the num is. And then if we run this, we get the desired output image. And I know I did have to add, release, and delete the COM object for the constant buffer. And then in terms of further work, the difference between constant buffers and shader constants are constant buffers are data buffers for DirectX to hold data that can be changed at runtime by the CPU, like we saw in question 4. And then the shader constants are the constant values of a constant buffer that don't change during an execution of the render pipeline. So if we look back at question 4, this would be a constant, a shader constant, and then the constant buffer was my CB color all the way down here. So that would be the constant buffer. And then the second problem was that when you were trying to add this type of coloration to an already created image, it's not going to happen because, even though the math is right, it's because the rasterizer has already created the pixels, all the pixels, and it takes place before the pixel shader. So if we wanted to do this before, we would have to do it before it goes to the rasterizer stage. Okay, and I think that's everything for problem for assignment 2. Okay.